that cross assignment or cross type assignment really quickly. I was thinking about how I explained it on Wednesday. It wasn't particularly good. It's pretty simple. Again, the things you have to remember is if you're assigning an integer to a floating point number, you're just going to get the integer component in the floating point number. So if I was to assign 10 to a floating point number, it would just be 10 point and then 6 zeros. And if I was to assign a floating point number, 10.11 to an integer, all I would have is 10 in the integer. It's pretty straightforward. The other thing I was going to try and talk about was the actual value behind characters. I'm going to open up so I brought this up really quickly on Wednesday, but I think it's important that we look at it one more time for what we want to look at. So when we say character, essentially one of the things I said on Wednesday was everything's a number. At its core, everything's a number. And one of the things we have to realize is that when we're saying character, when we have something and we say C, like that's interpreted by the compiler, and that ultimately generates a number, which is stored by the system. So when we say char A equals C, what we're actually going to do to figure out the value of A behind the scenes, we'd go to our ASCII table and we'd say A is equal to 97 right here. So we can see that we could say C, or we could say 97. Those are the same things. And when we go to it's really tiny still. And when we go to printf, we could printf say %C. And we could say 97 right there in line. Printf doesn't care, or basically what printf is going to do is it's going to interpret that 97 as being associated with the letter C. So in basic C, and for most of your programming here, you'll use ASCII. The main problem with ASCII, of course, is it can't represent a lot of characters from other languages. So you start moving into other encodings later on, like UTF, and it's basically UTF. That's the only one that matters nowadays. But so if you're interested in how characters are encoded from other languages, take a look at UTF. So we're also going to talk about arithmetic operations. So recall that we can do addition, multiplication, subtraction, division by just saying plus, minus, divide, multiply. So again, we can say int a. I should just open test. What's not column, but C. And I'll say slept through my alarm this morning, so
yeah, I did too.
Yeah, good stuff.
You have to call your sickness. I was just sleeping.
Hopefully you didn't catch it from me, but
Or whatever was going on.
so again, you can do
Well, people are bound to say there's many different people from different places and states, and all of them have different variants and such.
for sure. So talking about arithmetic and stuff, recall we can assign we can declare a variable and say 10 plus 10. So a will equal 20 there. We can say declare a and then say a equals 10 plus 10 right there. So just keep in mind, we don't really care about white space. We can have, for example, if we wanted to, we could have a billion spaces here. We could have space. We could go on to our next line. We could do this. We could make it as sloppy as we want to. What the compiler wants to see is one number, any number of spaces, and then an operator, and then any number of spaces, and another number. So recall, we can say something like 10 plus 10 plus 10 plus 10. And we can also string on minus, minus. We can string on as many operations as we want to on one line. And when normally we want to keep the number of operations limited on that one line, we can say as many as we want to. So recall that when we say something like 10 or something like C, that's called a literal. But we can reference a variable by saying a plus 10. So right now a doesn't have any value, so we don't. When we use declare a variable like this, we say int a, and we don't provide it a value, the operating system doesn't guarantee that a will equal any certain number. But now most of the time it will equal 0, but occasionally on a certain system it might equal 2 billion or 5 or 6 or any number. So if you do something like this, this result might be anything. Again, the operating system doesn't guarantee that a will equal any certain number. So we want to make sure that before we use any variable, we either set it equal to 0 at the top, or when we assign it, for the first time, we want to make sure we have only literals that we're assigning it to. So we can say 10, and right here, a will equal 20. Well, actually, no, it won't, because our program won't compile, because we're missing a semicolon. So a will equal 20 right there. Any questions about arithmetic operators or some of the limitations we can, or any of our limitations? Does that make sense to everyone? So one of the other things I'm going to cover today is actually compound arithmetic operators. So when we're doing something like int a equals, we'll say int a equals 0. And let's say we want to add 10 to a. So traditionally what we have to do is say a equals a plus 10. So there we just added 10 to a. But as it turns out, there's a thing called compound arithmetic operators. And what we can do is say the plus and the equals in one, or the operation and equals in one operator. We can say plus equals 10. So that will directly add 10 to a. We can say minus equals 10, and that will directly subtract 10 from a. So on and so forth. We can say times equals, and we can say divides equals. So just keep that in mind. It makes lines a lot easier. So remember, compound operators when we want to directly modify the value of a variable. So one other thing that I saw come up on some of the first assignments was division by 0. So why can't we divide by 0? I'll recall your basic math classes. So let's say we want to do a equals 10 divided by 0. Now let's see what happens here. Now, I think the compiler will actually stop us, but I already did ASDF. I'm a big fan of ASDF. So what the compiler actually will do, and this wasn't the case when I was writing my program just a few years ago, the compiler would not care if you tried to divide by 0, and it would let you go through. And what'll actually, I don't know exactly how to disable this warning. You can, if it says warning and it cancels your, actually, yeah, it'll say floating point exception. So it'll warn you, but it'll still compile and go through. But basically, your program will crash and it'll just say floating point exception. And floating point exception means quite a few different things in C. If you just, there's a number of operations that will cause it. It's not just division by 0. And if you're interested in those, go ahead and do some more research on that. But just keep in mind that you can't divide by 0 because we just can't divide by 0 because how many 0 are in 10? It just doesn't work. So another thing we can talk about is actually doing arithmetic on character values. So as we looked at before, every single character value has, well, every single character has a value. We can see that A equals 65 or S equals 83. And keep in mind there's a difference between uppercase and lowercase. And also all the number digits also have character values, but these values aren't necessarily 0. You can see 0 equals 48, so the character 0 is equal to 48. So what we can do actually is we can say char A equals, let's say my char equals A. And we can actually go ahead, well, I'll just print that off quick. So we'll do printf %cn my care. And then we can do this. We can say my care, and we're going to add 1 to it. So what comes after A then?
66.
Yes. So you could the two correct answers were either 66 or B, because recall A has the value of 65, and if we add 1 to 65, we get 66. So we've added 1 to my character, and then we're going to print it off quick. So you can see that A and then B. So we can manipulate characters in our in C by just directly adding or subtracting numbers to them. So that's really useful when we have things like, let's say we want to take the character 0, which has a value of 48, and we want to get the number 48. So what we can do is we can subtract, I'll just do it actually. I'll say my character is 0. So in order to get a number, we can say int my number equals my care minus 48. I think it's 48, right? Yeah, 48. So when we subtract 48 from 48, we get 0. And if we do that for any other digit we have, we can subtract 49, or we can subtract 48 from 49 and have 1. So for any digit that we have in character form, we can convert that to an integer value, 0 through 9, by just subtracting 48. So just to show you that that works. Thanks. So this should print out 0. Well, it should print out 0 twice, but for different reasons. Yes. So that's kind of difficult to understand, but does that kind of make sense to everybody, that we can take character values and we can interpret them as integers by default, and we can also convert their values to integer values that we can manipulate as numbers. Alright, so that basically covers all of the review topics I wanted to talk about today. The main thing I want to talk about today is scanf. So right now, we have basically, we have two functions that we can use. We can use puts to output a string, and we have printf, which we can use to basically mix in numbers and characters and different values into our string. So printf outputs. So scanf is very similar. It uses the exact same format as the printf does, but instead of printing, it reads into a variable. So let's say we have int my number. We can now, what scanf does is it accepts input from the console, from the terminal, from the user, and it stores it into the value you specify, or into the variable you specify. Okay, so we can say scanf. So it's just like printf. It takes a format string describing what arguments you're going to give it. So since we want to read an integer, we'd say %i, and then in order to say where we want to store it, we say an ampersand my number. So basically what this says, the statement means, is it's going to read in an integer, which is specified by our format string. So this means we're going to read in an integer, and we're going to store it. That's basically what... we're going to talk about more about the ampersand later, but the ampersand can basically be thought of as into my number. So we're going to read an integer and we're going to store it in my number. So in order to give our program that value, we run it, and we can see that the program stops there. Now the program has stopped waiting for us to input a number. So we can say 11. And it'll output 11 because we stored 11 in my number, and then we immediately printed it off. So we can do this for other variables as well. We can say float my float, char my char. So there's a couple different ways we can do this. We can do it, I can't say for sure, but I'm pretty sure we can do it all on one line. We can say C. So %f%c. So we're going to read all of our numbers, or all of our values on one line. We're going to say my float, my char. And then we're going to output them all in the same line. So we give it one of those, one of those, one of these. And we can see that the interpreter, the first number is an integer, the second as a floating point number, and the third as a character. And it stored them in the correct variables and outputted them the same. But keep in mind that we have, I don't know exactly how this will work. If we say, I'm pretty sure the 10, so if we provide the wrong type of, so let's say we provide a floating point number for where an integer should be read in, and the integer for where a floating point number should be read in. And let's try and give 65 for a character. Now I'm pretty sure what will happen is it'll read in 10 to the integer, 10 to the floating point number, and probably 6 to the character. And I was completely wrong. So what it ended up doing was reading in 10. Okay, so it read in this component to the integer portion. It read in this component to the floating point number, and it read in this component to the character. So just keep in mind you want good separation between where you're inputting these values from, and that you need to provide the correct type. So this is an integer, remember. This is floating point number, this is character. These values need to stay in this order, because when scanf, just like printf, when it finds this first format identifier, it looks at the first position. And when it finds the second format identifier, it looks at the second position. And scanf's really tricky. If you accidentally put in a character, it might do weird things. Scanf is definitely a lot more tricky than printf. And one of the things you might be tempted to do is say something like, let's say your user input something before the scanf, and you want to say hi. Let's say your user types hi, then 10, then 10.1, then C. But you can't do that like you can with printf. The only thing that you can put in a scanf is format identifiers. So that was one of the things that when I was learning this caught me up. I thought I could put things inside there that would kind of eliminate that. Like let's say I wanted them delimited by, maybe I can do this. I'm not sure. Like I wanted them delimited by 2 spaces instead of 1. But I'm almost positive that you can't do that. It'll read the first integer, it'll read the first floating point number it comes across, and it'll read the first character it comes across. So that's kind of the basics of scanf. Just remember the essentials. In order to make it really easy, you can just have one format identifier and one variable. Just recall that you'd say hi for integer, f for floating point number, c for character, and then you'd say an ampersand, and then the variable you want to store it in. So that's the basics of scanf. Okay, so I'm going to talk real briefly, oh goodness, about assignment 3. So if we head on over to D2L, I'm just having internet problems today, I guess. Thank you. You're so bad. You're fine. You're at least you're giving input to the class.
We're funny, alright.
Something like that.
Deal. What you up to this weekend?
Activities.
I'll see you there.
We'll see about that one. So, so assignment 3, again, we can find our assignments every single week. I'm going to just drop them in which week we are on, and then assignment 3. So, assignment 3 shouldn't be too hard. Does require you to understand scanf, understand printf. But for it, all I want you to do is create a program which calculates sales tax. Basically, you're going to read the subtotal of an order in, you're going to read the tax rate in, and then you're going to output the total for the order. So it's pretty much as simple as that. You just enter. So this would be example program with just the output. So you prompt the user to say enter the subtotal, and you prompt them for enter the tax rate, and then you print out the total is $, and make sure that. And another thing that I didn't necessarily mention as well as I should have is you want to say the total is, and you want to say $, and then 2 decimals. So $, 2 decimals is really important. We're dealing with money. That's just how it's formatted. So then with a program that has input would look like enter the subtotal. User would type 10, enter the tax rate. User would type 0.07, 0.1, enter, and then you'd say the total value. Then I'll just run this sample program. So most of the time I'm always going to copy a sample program for the assignments into the dist folder. So to get there you could cd dist. You can see all the things that I've dropped in there. Otherwise, if you don't really care, you can just do dist, and you can just tab, and it'll show you what's in there to run. So the program that I've written is assignment 3. So it'll say enter the subtotal. I'll say $10. Enter the tax rate. I'll say 0.07. And it'll output 10.70. So it's a super simple program, but it does require you to understand how scanf works and how printf works. So again, that's due Wednesday at 11:59, this coming Wednesday. So that is the 11th, 12th, 13th, 14th, 15th. We'll just look it up. We won't try and count it. So that is September the 16th. So try and think about that if you don't understand scanf, printf. Think about those items. Try and understand them. By the time you get back on Monday, we can talk about it more then. If my internet would... There we go. I think my presentation is finally synced. Years later. So it's not the actual program. I didn't give you the C file. What I gave you is an executable that you could run. So you do /dist/assignment2, and then it will run the program. What now? Oh yeah, I'm not gonna literally give you the program so you can submit it. That's just not gonna happen.
Yeah. You sure?
All right. Yeah, I'm positive for sure, 100%. Definitely not gonna change. So just recall that when we run a program, we can do /a.out. And what that does, stupid program, it will go in the current directory / and then a.out. We always have to specify the full path. It's just that dot expands to where you're at currently. So when I say /dist/assignment2, that will go up to /, then I go to the dist folder, then I'll go to assignment2. So let's look at the Linux file structure. So right now, you all have a directory that you're in, and it looks like that's where you can go. But as a matter of fact, you can go up higher. You can go, let's say I'm, so right now you can figure out where you are by saying pwd. and that means print working directory. And I'm in home/Alex. Now, you can cd ... to go up a directory. So all of you actually are in the 150_F15 directory. So you can see that's all of your user folders. And when you log in, you're dropped into the user folder that's respective to you. But you can navigate around the file system if you want to. So looking at a diagram like this, you can see that there's a bunch of different directories on Linux by default. And typically, all of the users are stored in the home directory. All the binaries that you run are stored in either bin or user bin. So when I run GCC, it's kind of hard to understand where that comes from. It doesn't necessarily matter that you understand this, but echo path. So looking at our path, what path is that's where executables exist that can be run without /. Basically, when you run GCC, it'll look through that list of paths and it'll try and find that binary and run it. Now, again, this isn't really important to understand, but it's kind of interesting to understand where GCC exists. So you can say which GCC, and it'll tell you where GCC lives. You can go to cd user bin, and you can see there's a bunch of commands, but let's find GCC in this list. Yeah, that's not worth doing. But you can navigate around, so when I go cd/, that's the root of our file directory structure, and that'll show all the files that are available for use on the system. So I've actually made that /dist folder you can see it right here. And basically what that does for me is I just can drop files in there, and then you only have read access to them. You can look at them, and you can manipulate them however you want to. So again, dist folder. It's owned by me, but you can look at it. So
what folder do we have all on?
So again, we'd go to get back to your home directory, you can always just cd. Just type cd, nothing else. But if you want to see exactly where you are, your home, 150, and then now I can't go there just right now as my user. I could go there if I wanted to. But if you were Austin Cole, you could say cd home 150f15 / your username, and you could go in that directory. And then it would show as the let's talk about I like Linux, but talking about Linux is fun for me. But again, completely not particularly relevant to this course. As long as you're able to compile files, edit them, you're good to go. But
question.
Yes.
What file are submitted homework in?
So that's actually really hard to explain. I did a bunch of voodoo to get that system to work, but we can talk about that at the end of the semester, I think, if you really care to know. A lot of people told me I couldn't make that system work, but I made it work. So just a couple things again, just a couple characters to remember in Linux. So there's the dot, which is current directory, ... directory above the current directory, and tilde, I think that's tilde, right?
Yeah.
Which is your home directory. So you might notice that it'll say your username @dev, semicolon, tilde, which tilde means you're in your home directory. So I could go up, and it tells me exactly where I am, but I go Alex again, and instead of saying home/home/Alex, it'll say tilde. It will replace that /home/Alex with tilde. Again, kind of cool, kind of interesting if you care about what's happening, but I get it. So, really quick, let's do day 8 in class. So basically what we do is read in an integer character floating point number, perform a math operation on each, print the result, and submit it to day 8 in class.
So read in, that means do the ampersand or whatever.
Yep, do scanf.
an int